In this video, we have to understand how to check RAM in Linux. It seems like very easy to check RAM on Linux, but it's a challenging job. So let's start. I have a Linux machine and a free command we can use to check the memory. If I use -m switch, it will give us in the megabyte about memory and swap information. If you run here the G or K, it will give you the in gigabyte or kilobytes. So since I have just 4 GB of RAM, that's why I use in megabytes. So this is the total amount of memory, physical memory. And swap is disabled since this is my Kubernetes node. So Kubernetes swap is by default disabled. So total is this, but what about this used, free, shared, buffer cache and available? So we have to understand all these concepts. So if we look into the used, so used we can say is the amount of memory that 447 megabyte used by the processes running on our Linux machine. Okay, so if this is the used amount of RAM, then why the value of free is not equals to total minus used? This is not equals to total minus used. And what is this available? So we can understand this free and available after making a clear understanding about shared and buffer and cache. So first of all, we will understand the shared, then we will look into the buffer cache. So let's start with the shared. So to understand the shared, we need to understand the tempfs file system in Linux. Tempfs file system is a very robust file system to increase the performance of write and read operations. So there are some temporary file system required by the Linux operating system and kernel to write and read the data. But that data is not imperative on next boot. It is the data is lost. So tempfs is basically a temporary file system and it is based on the memory. So we can see here there are two, three, four, and there is one more tempfs, and there are different directories mounting this tempfs, and each tempfs has its own size. So this is decided by the Linux you are using, but in fact it is mounted in different directories path, and each directory is used for the different purpose. Here we are not going to understand that what are these directories for, but we just have to make a sense that tempfs is used to provide the robust read-write operation. So these directories are important to write the data during the boot time or during some operations in the Linux operating system. So its max memory of tempfs you can allocate the 50% of your total memory. So we have 4 GB, so 2 GB max is allocated. Rest of all are less than 2 GB, that's 5 megabyte and 391 megabyte. So the shared that if we look here, that is just use 2 megabyte. Actually, the space occupied by the tempfs. So let's go in some directory, for example, in dev shm. I'm going in this directory, and this is actually pointing to the memory. Whatever I will create here, it will go in the memory. So let me just copy something like the complete etc directory I'm copying here. It will copy, and then I will run this free -m command again. So we will understand that the shared has been increased. Free -m now shared is set to 318 megabyte. Previously it was just 2 megabyte. So it's mean whatever is going under the tempfs mount points is declared as shared. Okay, now if we look into the free and available, it is also changed 1569 and 2917. Previously it was different. So this tempfs actually occupy something from the RAM. That's why this free and available is changed. So now we will understand about buffer and cache. Then we will jump into the free and available concept. So buffer and cache is basically the memory that is used by page cache, D entries, directory path entries, and inodes. Page cache, this is the main file data cache. Whatever we are reading consecutively from the hard drive, and the same files if we are uh, reading each time from the hard drive by us or by processes or by some network services, whatever is reading the data. So kernel will notice that this file is the most frequent used file. So to reduce the disk pressure, it will cache those files in the memory. And in that part is known as buffer and cache. Second thing is D entries. This is basically directory entries. These are the directory entries. The kernel use a D entry cache to store information about recently accessed directories, which speed up the path lookup. So either we are using different path or the kernel is using. So this is just a cache for different path. Inode we discussed in very detail in our Linux training part. This is the metadata about the data. So an inode is a data structure that store information about the file or directory on the file system. The kernel cache inodes to speed up file system operations. So inode, just to let me give you a quick idea about the inode. For example, I have some files here. Let me. Stat is a command that can give you the data about the metadata. Uh, the data, metadata about the data. So VPC, for example, this is a file. Just looking what is the metadata of this file. So this is a regular file. It has some name, size, this path of this file actually residing on the hard drive, inode number, permissions, user and group ownership, access time, modify time, everything is mentioned here. And this is inode R is residing in the indexing area of any partition. So whenever you are opening any file, so the Linux is the head of the hard drive is pointing to the indexing area and just looking the inode, and then inode give that exact location of the file, and it is head is jumping to the that location. So this is also known as the random access file system. So we understand about these three things. So the some of the page cache and inodes and d entries, and I believe there are some other stuff too that is also buffer and cache, that is also related to buffer and cache. So let me just run this command again. So this 19111 is a combination of these three things. We can clear these three things from the buffer and cache, but we cannot make this buffer and cache to zero. We can make shared up to zero if we clear all the tempfs file system mounted, but this is not possible to make buffer and cache to zero. Even we clear all these three types of cache. Why? Because some part of the buffer and cache is related to the kernel and running operating system information, and that is not clearable. If we clear that information, that is not in our hand, but if we forcefully clear those, our operating system could crash. So let's now understand if we clear some stuff from buffer cache, how it will work. So I will now there is a command in the proc, the proc is a file system where directly we can give some signals to the kernel to perform some operations, or we can change some parameter related to running kernel. So in this in this file, we can throw a signal of bitmask. Its value can be 1, 2, or 3, and each bitmask will have its own effect on these three entries: page cache, entries, and inodes. So if we set the bitmask to 1, it will clear the page cache, whatever the related to the hard drive data cached on the RAM memory, it will clear. If we do echo 2 to this file, it will clear the dentries and inodes. And if we do 3, it will clear all these three. So let's just do an echo 3 to so that we will clear all these three cache stuff. So I'm sending this signal free minus m. Now you can see it's reduced to 710. So it's mean it can max reduce up to this. Remaining why 710 is remaining 710 is related to something that is crucial to run the system. And you also notice that this amount of free is also change as this amount is change. This amount of megabyte is change. It is directly related to free. So since we understand shared, we understand buffer cache. Now we will understand this free. This free is the actual free amount of memory that is mean freely available to be occupied by shared buffer cache and by the running processes or any new process want to launch in this system. So this free amount of RAM is there. Now, what is this available? So free and available seems like same, but it is different. Available is actually what can be available. Mean if we clear this shared and buffer, so whatever we can still occupy from our memory that is used by buffer and cache, we can take control of some more memory to launch the processes, and the actually forcefully hand available memory is 2916. So if I you see its difference is very less because we can now only clear this shared. We cannot clear buffer and cache. Whatever we throw the signal, we ran the command, this one, we cleared the max what we can do. So here you can see the difference is very less. So let me now clear the this shared whatever I copied here etc in the def shm, that is tempfs, and again run the free minus m. So it is now reduced, and here you can see the difference. The amount of available memory has been increased. So this much amount of memory we can more grab from by clearing the shared and buffer cache. So this was the concept related to memory. So the free and available you can quickly differentiate, like free is the currently available and available can be available.